Alrighty, this is the third installment of section 8 from chapter 5, the rational zero theorem. This section we are going to solve completely. It doesn't matter what kind of roots. We're going to start with the rational ones, and then from there we'll work, and we'll also find imaginary ones if they exist as well. It's really going to be like part 2, only we're just going to finish the problem this time. So let's just dive right in. We've got example 3, where it says find all the zeros. So that means real and imaginary here. All right, let's do our sign check first to figure out what kind of roots we have. Then we'll figure out our rational zeros and go from there for solving. So if we look, positives, no change, no change, no change, change. Okay, then let's deal with the negative side of things. So I'm plugging in a negative value. Yep, oops. And let's see here. We have 8x to the 4th minus 2x cubed plus 5x squared minus 2x minus 3. So we've got a change. We've got another change, and no change. So let's start filling in our chart. Positives, negatives, imaginaries, and total. So total, we have to have a total of 4, right? That tells us how many roots, how many zeros we're going to have in all. So positive, we have 1. Now for negatives, we could have 3, or we could have 1. So if we have 3 negatives, then we have no imaginary for a total of 4. If we have 1 positive, 1 negative, that means we have 2 imaginary for a total of 4. Remember, when you have a number large enough where you can subtract 2 and have something 0 or greater, go ahead and do that. That gives us 2 different options. Now, let's figure out our rational zero possibilities. That will help us get started knowing what numbers we could be plugging in. So we're going to need to have the factors of 3 and the factors of 8. So for P, we'll have factors of 3, plus or minus 1 and plus or minus 3. For the factors of 8, we will have the they are plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Which means our rational zeros are going to be 1 over all of these numbers and 3 over all of these numbers. Okay, so let's do that and reduce fractions as you go. So let's see here. That means our rational zeros are going to be 1 over 1 is 1, so plus or minus 1. And then plus or minus a half, plus or minus a fourth, and plus or minus an eighth. 1 over each of these. Then 3 over each of these numbers. 3 over 1 is just 3, so we'll have plus or minus 3. Doesn't really matter the order you write these in either. Plus or minus 3 halves, plus or minus 3 fourths, and plus or minus 3 eighths. Some people like to go put it all in numerical order. I just like to go along and go, okay, 1 over all the q's, 3 over all the q's, and we call it good. And from here, we're going to use these numbers to help us solve. Now, ideally, we're going to start with nice numbers that are going to work. Like, I'm going to try the 1s and the 1 and the 3, the integers first. Then we'll start dealing with fractions. All right? All right, so we could have a positive, so let's try 1. And we have descending order of powers, which is good. So we can go 8, 2, 5, 2, and negative 3. 8 comes down. 1 times 8 is 8. 2 plus 8 is 10. 1 times 10 is 10. 5 plus 10 is 15. 1 times 15 is 15. 2 plus 15 is 17. 1 times 17, 17. Negative 3 plus 17 is 14. All right, so 1 is not it. All right, let's try another one. Let's try 3. Or you might say, no, I just want to work my way along. Let's just try a half. All right. Well, I'd say let's try 3 because, well, it's Why deal with fractions unless you have to, right? So let's go 8, 2, 5, 2, and -3. If this doesn't work, let's try a fraction. Bring down the 8. 3 times 8 is 24. 2 plus 24 is 26. 3 times 26 is a larger number, 78. 5 plus 78 is 83. Oh boy. 3 times 83 is 249. This is why you sometimes want to leave yourself some space. 2 plus 249 is 251. And 3 times 251 is 753. -3 plus 753 is 750. I don't know about you, but I don't think that's it. Should we try a half? Should we see how that goes? Should we try a fraction and see if that works for us? Oops, that doesn't look right. All right, here, let's try that again. We're going to do this the exact same way. We're going to write in 8, 2, 5, 2, and -3. All right, bring down the 8. Half of 8 is 4. 2 plus 4 is 6. Half of 6 is 3. 5 plus 3 is 8. Half of 8 is still 4. 2 plus 4 is 6. Half of 6 is 3. -3 plus 3 is 0. So here's an instance where knowing these rational zeros and knowing we could have fractions helps us because we pick one and it works. Now we suddenly have something. We have x minus a half and 8x to the third plus 6x squared plus 8x plus 6. All right, now as you look at that, all right, well, we're going to have to do synthetic division again. Now, one thing you could do is if you could say, well, I could factor something out, right? You could factor out a 2, or you can just use this and continue using these possible rational zeros up here. Now, remember, we aren't going to have any more positives, so we're going to go with all negatives, and we're going to go have to work our way up and just use these same ones again. Okay, so let's see what we end up with here. So we'll hang on to that half, but now let's see. Let's pick, well, we know it won't be 1, and we know it won't be 3, because once they're out, they're out. And we have to have a negative because we have our one positive, so I guess we either go with -1/2 or -1/4. Let's go with -1/4 for right now. Let's see if that works. So we got 8, 6, 8, and 6. So we're using the coefficients and the constant from our new depressed polynomial. Bring down the 8. -1/4 times 8 is -2. 6 minus 2 is 4. -1/4 of 4 is, oh boy, haha, sorry, -1. There we go. Wow, my brain didn't want to work for a second. 8 minus 1 is 7. -7/4. Okay, so see, this gets a little yucky, but we can survive. 6 minus 7/4 is, 6 minus 7/4 would be 17/4. You can just use your calculator to help you with that if you would like. Remember, you can keep it in fraction form and everything. So we'll say it's 17/4. Okay, so that's not it. Let's try negative. Well, we can try a lot of things. We could try eighths, or we could try fourths, because it felt like a fourth. It wasn't terrible until right here at the end. So maybe kind of go with your gut a little bit. See what happens if that works. Yeah, if that, you at least felt like things would cancel a little bit better. So let's maybe try that. Because whenever possible, it'd be nice to have things cancel, right? So let's try -3/4. I mean, it's still a little bit of guess and check out of these that you're choosing from. So, you know, it's up to you what you pick. And let's see, 8, 6, 8, 6. All right, -3/4 of 8 is -6. 6 minus 6 is 0. -3/4 times 0 is 0. 8 plus 0 is 8. -3/4 of 8 is -6, and so that's 0. Boy, didn't that work out well. All right, now that means we have another root. We have x minus a half, we have x plus 3/4, and we have 8x squared plus 8. So this one, we can just take and set equal to 0, and say 8x squared plus 8 equals 0, subtract 8 from both sides, 8x squared equals -8, divide by 8, x squared equals -1. When we go to take that square root, ladies and gentlemen, what happens? Oh yeah, we end up with x equals plus or minus, remember, plus or minus, I. So that means all of our zeros are 1/2, -3/4, and plus or minus I. There we go. There's our final answer. Now, the next two examples, we're going to work through them, and if you want, you can pause the video, solve, and then come back and check your answers, okay? Well, let's take a look. I'm going to slide this up. All right, so number 7. Let's take a look at this and see if we can do our best to keep things ourselves organized here. So let's look. Sign changes for the positives. Nope. Yes. Yes and yes. All right, so let's remember that. That's for positives. And then we'll do negative. Hopefully we're to the point now where we are remembering that if we put in a negative on an even power, it's going to keep it the same sign. So we're going to have x to the 4th. And if we have an odd power, it switches signs. So I'm just going to write it out and hopefully save ourselves a little bit of time and space. So we've got a sign change, no sign change, no sign change, and no sign change. Okay, which means, make sure I'm not writing off the video here. There we go. Okay, we make our little chart, P, N, I, and T. Positives, we could have 3, or we could have 1. We could have 1 negative, and how many do we have in total? That's right, we have 4. So we'll have 3 positives, 1 negative, no imaginary, or 1 positive, 1 negative, 2 imaginary, for a total of 4. Now, we have to factor 60, find the factors of 60 and the factors of 1. Well, good news, factors of 1 we can do. Those are easy, right? All right, let's see here. Let's go with, all right, let's see, our factors of 60. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 5, plus or minus 6. Let's see, no 7, no 8, no 9, plus or minus 10, plus or minus 12, plus or minus, let's see, that pairs that, 15, plus or minus 5 and 12, 15 and 4, 3 and 20, there we go, plus or minus 30, and plus or minus 60. And then, of course, Q is just plus or minus 1. All right, so these become our rational zeros here. That's what we're working from. 1, 2, 3, 4, 5, and the negative versions. All right, so that's where we're going to start. Let's start there and let's pick a value. Let's try, I don't know, should we start with positives because we know we're going to have a positive? We also know we're going to have a negative. So let's start with 1. Now, check your powers. Yep, we've got descending powers, so we can go 1, 2, negative 11, 8, and negative 60. Now, always remember, if you're missing a term and a power of x, you've got to put in a 0. Otherwise, you're going to mess yourself up. Bring it down. 1. 1 times 1 is 1. 2 plus 1 is 3. 1 times 3 is 3. Negative 8, or negative 11 plus 3 is negative 8. 1 times negative 8 is negative 8. That's 0 then. And we end up with 0, so we have negative 60. That's no good. That's not going to help us. All right, let's try another one. Let's go with 2. 1, 2, negative 11, 8, and negative 60. Always watch your signs as you're doing this. Bring it down. 1, 2, 4, 8, negative 3, negative 6, 2, and 12, negative 48. Well, that's not it either, is it? This could be a problem. Well, I guess we try something else, don't we? All right, let's try 3. If it doesn't work, maybe then we'll switch over to a negative. We'll see. All right, so 1, 2, negative 11, 8, and negative 60. 1, 3, 5, 15, 4, 12, 20. Oh, look at this, guys. We have a factor. We have x minus 3 times x to the third plus 5x squared plus 4x plus 20. All right, now we can't just use quadratic formula this, so guess what? We're going to synthetically divide again. However, we know 1 and 2 are out. We know we have to have a negative, so we could see if we could make a negative work, or we could keep going with positive, see if there is another positive. Personally, if it were me, I would start with the negative since I know I have to create a negative here and I don't know whether I need another positive number or not. So that's what I'm going to do. All right, now, let's start with negative 1. Okay, let's see. So we're going to use our numbers here from our depressed polynomial. So now we're going to have 1, 5, 4, and 20. Now, let's see here. Bring this down. 1, negative 1, 4. Let's see. Yep, negative 4, 0, 0, and 20. Not it. Negative 2. Let's see. 1, 5, 4, and 20. 1, negative 2, 3, negative 6, negative 2, 4, and 24. Not it. Now, are any of you looking at this going, I see a 5, a 4, and a 20. I feel like I should try a negative 4 or a negative 5, you know, kind of using your gut instinct here. If you see that and you want to try something like that, go for it. Just don't lose track of the numbers that you've used. But, you know, you sometimes feel like you see certain numbers maybe, you know, that are factors of each other, how the coefficients are all factors of each other, or factors here. Maybe that becomes one of the factors overall. So, should we try negative 4 or negative 5? I think we should. Let's skip negative 3 for right now. All right, so let's see, we still have to go 1, 5, 4, and 20. Bring down a 1, that's negative 4, that's 1, that's negative 4 again. That's 0, that's 0, that's 20. Okay, well, it wasn't that, but it's not all bad. Let's try negative 5. 1, 5, 4, and 20. Bring down a 1. Negative 5 is 0. That's 0. Bring down a, that's 4. That's negative 20. Hey, it worked. So see, using our gut instinct of seeing related numbers, factor families, things like that, helps us out. So now we have our first factor, x minus 3. We have x plus 5. And what do we have left? We have x squared plus 4. Well, we have one positive, one negative. And what's left, we've probably seen enough times now to know that's going to be imaginary. So we're going to be looking at that scenario there. So let's finish this off. X squared plus 4 equals 0. Subtract 4. X squared equals negative 4. Square root. X equals, remember when you're taking the square root for a variable, it's plus or minus 2i. So we've got two imaginary, a negative and a positive root. So our x equals negative 5, positive 3, and plus or minus 2i. That is your final answer, ladies and gentlemen. And now we have just one more problem to do. I'm going to slide this over just so that we can see the whole page. Draw a little line to give us a little separation between the two problems. And say, all right, let's give this a shot. Now, this problem, this one's going to be a little more work. All right, so we've got x to the fourth, 5x cubed, plus 30x squared plus 45x minus 54. Let's check our signs, make our little chart. Okay, no sign change, no sign change, no sign change, sign change. Now let's do the negative version, and I'm going to say, remember our rule. If it's an odd power, it changes sign. If it's an even power, it keeps the sign. So let's not waste our space with writing out a whole extra step. So 4x to the fourth minus 5x cubed plus 30x squared minus 45x minus 54. So let's see, we've got a sign change, a sign change, a sign change, no sign change. Okay, now let's see here. That means for positives, we have 1. Negatives, we're going to have 2 possibilities. And you notice our total is 4. So negatives, we could have 3 or 1. So it's going to kind of be like last time, sort of. Here we have a total of 4. So 1 positive, 3 negative, no imaginary, or 1 positive, 1 negative, 2 imaginary, for a total of 4. Now we just have to figure out what our rational zeros are. What are our possibilities? Oh boy, we got to find our factors of 54 and our factors of 4. Okay, so this one's going to be a little work. Factors of 54, 1, 2, 3, let's see here, 6, 9, 18, 27, and of course 54. All right, now we also have to find our factors of 2. Plus or minus 1, plus or minus 2, and plus or minus 4. Now we've got to pair all of these together. Well, we know we'll take all of these factors, put them over 1, and they're all those numbers. Then we got to put them over 2. Okay? So here come our rational zeros. There are a lot of them. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18, plus or minus 27, plus or minus 54. Now, let's take 1 over 2 is a half. So we can have that one, plus or minus a half. Remember, we reduce fractions. So 2 over 2 is 1. Oh, we already have that one. Plus or minus 3 over 2 will be one of them. Plus or minus 6 over 2. That's 3. We already have that. Plus or minus 9 over 2. We better keep that one. Plus or minus 18 over 2 is 9. Plus or minus 27 over 2. You notice we're keeping the odds, aren't we? Plus or minus 54 over 2 is 27. Okay. Now, all of these over 4. So plus or minus 1/4. Plus or minus 2 over 4 is 1/2. Plus or minus 3/4. Plus or minus 6/4. Oh, that's 3/2. Got that one. Plus or minus 9/4. 18/4. What does that reduce to? 9/2. Oh, wait, we already have that. Plus or minus 27/4. And then plus or minus 54/4 reduces to 27 over 2. So these are our rational zeros. These are the numbers we're going to try and use in synthetic substitution to help us solve. All right. Let's start picking numbers. Oh, let's see here. Well, where do you want to start? 1's always a good choice. Let's start with 1. All right, we have, let's see, they're all in descending order, so we'll go 4, 5, 30, 45, and 54. Bring down the 4. 1 times 4 is 4, 5 plus 4 is 9, 1 times 9 is 9, 30 plus 9 is 39. 1 times 39 is 39, 45 plus 39 is 84. Uh-oh. This is going to be too big, isn't it? 1 times 84, 84. We're going to have 138. That is not it, except that this should have been a negative 54. Pay attention to your signs. See, even I messed that up. Negative 54 plus 84 is 30. Still not it. So, didn't totally mess ourselves up. Okay, let's see here. Let's try another one. Shall we try 2? 4, 5, 30, 45, and negative 54. See, I got it this time. 4, that's 8. 5 plus 8 is 13. 2 times 13 is 26. 30 plus 26 is 56. 2 times 56 is 112. 45 plus 112 is 157. 2 times 157 is 314, and negative 54 plus 314 is 260. Well, if it wasn't 1, it's definitely not 2. Seem to be heading in the wrong direction. I don't know. Anybody have any gut thoughts about this one? Maybe we should try a fraction. So we pick one? Let's see here. Should we try 3/4? It's going to be a lot of guessing and checking, so it's your best guess as to what it might be. 4, 5, 30, 45, and negative 54. Let's see how this goes. What I like about it is the first time you go through, if you pick something with a 4, it's going to cancel out, which maybe means it'll happen again. You never know. So what's 3/4 of 4? It's 3. 5 plus 3 is 8. All right, 3/4 of 8 is 6. Okay, well, that's encouraging. The fractions are staying gone. 30 plus 6 is 36. 3/4 of 6 is 27. Let's see, 45 plus 27 is 72. What's 3/4 of 72? It's 54. Yay, that's one of our fractions. That's one of our factors then. Now, if you're going, how in the world did you decide to pick that? I guessed. Sometimes you just have to guess a little bit. And I thought, well, I at least saw that in my first term, like I said, I could see the 4 and the 4th canceling out. Boy, that seems nice. My other thought would have been to pick something over 2, because I'd also know it would have canceled there as well. So, you know, it's a little bit of guess and check still, but at least we have a slightly smaller amount of numbers to choose from. Okay, so we've got x minus 3/4, 4x squared, or nope, cubed, plus 8x squared plus 36x plus 72. So now if you look at the problem, you will see that we could factor out here. We could factor something out of the parentheses. We didn't do it last time. We kept going and it worked fine. But maybe you say, I don't want to work with numbers this large. I don't blame you. What can we factor out? We can factor out a 4. So let's just write that in front. X minus 3/4. We'll just write all the way out in front because we just don't need it right now. So you have x cubed plus 2x squared plus 18x plus, oops, not 18x, sorry, 9x plus 18. There we go. Now we're going to use synthetic substitution here. Now we have a positive root. We know we have our one positive. So now it's time to think negative. Let's try some negative numbers. Now, what does your gut tell you to do? I see a 1, a 2, a 9, and an 18. Could one work? Could negative 1 work? Possibly. But the last time when we had something like that, it ended up being one of the two middle numbers. It's negative version, but you know, it's still one of those two middle numbers. So I'm going to say, let's try negative 2. We've got 1, 2, 9, and 18. 1, negative 2 is 0. Yep, 0, 9, negative 18, and it worked. Boy, isn't that nice when that happens? Now, we have 4. We have x minus 3/4, x plus 2, and x squared plus 9. Okay, so we have one positive, one negative, and this is going to become an imaginary one. So we're going to be working with this scenario right here. Let's finish off our problem. This 4 will just fade off into nothingness. We don't have to worry about it. Go up here. X squared plus 9 equals 0. Subtract 9. x squared equals -9. Square root, remember? Plus or minus 3i. So our final answer is x equals 3/4, x equals -2, and plus or minus 3i. There we go. That is how you solve using rational zeros. Happy practicing!